Something huge just happened at Google. Quietly but unmistakably, they dropped not one, not two, but 3 breakthrough AI systems in just a matter of days. And each one is gunning for a different arena: research, engineering, and Earth-scale intelligence. These aren't incremental upgrades. They're strategic weapons, each built to dominate high-level tasks that used to be uniquely human. Writing deep research reports, engineering full-blown machine learning pipelines, and mapping the entire planet on demand, like a virtual satellite. Let's start at the top, with the system that sounds like a secret military project, TTDDDR. It stands for Test Time Diffusion Deep Researcher. The name's forgettable. What it does isn't. Most AI research tools today are stitched together duct-tape jobs. They scrape summaries, generate fluff, and collapse when asked to reason beyond 2 steps. TTDDR doesn't play that game. It models the entire human research process: plan, search, refine, draft, rewrite, validate, and publish. It starts messy, like a real rough draft, but then it evolves, sharpening the output step by step, like cleaning a blurry image until it's crisp. And unlike most LLM agents, it doesn't rely on static data. It pulls in fresh external info at every single stage. Every draft iteration improves with new context, like an actual researcher grinding through the problem. Google threw it into the deep end, high-difficulty benchmarks requiring multi-hop reasoning and long-form logic chains. And it delivered. In head-to-head tests with OpenAI's own research agent, TTDDR crushed it, winning nearly 75% of long-form matchups. Even on short-form queries, it clocked in up to 8% better in accuracy. But where it really won? Depth, clarity, and coherence. It runs in 3 stages: planning, iterative search, and writing, each powered by its own internal agents that learn from past mistakes. Google calls this self-evolution. It's not just prompt tuning, it's architecture that adapts mid-process. It runs sequentially, in parallel, or on a loop, until the output lands. OpenAI scored slightly better on GIA, but when it comes to real research, TTDDR leads. Now let's talk code. MLE Star. You might think this is just another AutoML assistant. Nope. This is a full-blown machine learning engineer with zero ego, zero burnout, and insane execution. MLE Star takes a machine learning task, say regression or classification, and builds out real working Python code. But here's the kicker. It doesn't just spit out the usual boilerplate. It searches the internet for the latest SOTA models, vision transformer, efficient net, not stuff that went stale 5 years ago. It's selective, strategic. It adapts the architecture to the data. Once it generates the pipeline, it tests. It pinpoints which components actually move the needle. Feature engineering, ensemble logic, training tricks, then focuses fire on that. It refines. It loops. It self-optimizes until the metrics break through. And when it builds ensembles, it doesn't do dumb majority voting. It generates its own merging strategies. It proposes candidates, builds logic to fuse them, runs it, checks results, and tweaks again. All autonomous. Now, LLM-generated code is notorious for breaking stuff. Google saw it coming, so they bolted on 3 built-in safety nets. Number 1, a debugging agent to catch runtime errors. Number 2, a data leakage checker to prevent test, teach, train contamination. Number 3, and a data usage checker to make sure every source gets used. That last one, massive. A shocking number of models skip JSON or ignore satellite data just because CSVs are easier. MLE Star doesn't make excuses. When they benchmarked it on Kaggle tasks using MLE Benchlight, the results were insane. MLE Star medaled in nearly 2/3 of all comps and pulled gold in over 1/3. That's triple the win rate of the previous best baseline. Triple. Zoom in, and you'll see how smart this thing really is. While other agents default to ResNet on image tasks, MLE Star pivots to better architectures without prompting. Give it human guidance? It adapts instantly. It even corrects hallucinated code. Like when a model tries to normalize test data with test stats, MLE Star flags it, rewrites it, fixes it. No babysitting needed. This thing isn't helpful, it's elite. A self-tuning, debug-proof, full-stack ML engineer you can run with Google's Agent Development Kit today. But that's just local power. Now we scale global. DeepMind just rolled out something called Alpha Earth Foundations, or AEF. This is their move to solve a planetary problem we've had for decades. How the hell do we make use of all the data being beamed down from satellites, radar, drones, sensors, climate models, all of it? There's too much. And worse, it's unlabeled, fragmented, and noisy. Most of it sits unused. You might have infrared scans of a flood, but without on-the-ground truth, it's not actionable. AEF flips the table. It acts like a virtual satellite, not dependent on when the next satellite pass happens. Instead, it ingests everything, from 2017 to now, and builds geospatial embedding fields. These are high-res tiles packed with info: terrain, vegetation, infrastructure, climate, whatever. And the compression? Wild! Each tile fits into a 64-byte vector, 16 times smaller than anything else in the field, with zero loss of accuracy. AEF fills in missing data, handles cloudy satellite gaps, stitches scenes together with learned associations, and under the hood, it's using what DeepMind calls space-time precision architecture. That means it processes across 3 axes simultaneously: space, time, and resolution, using attention layers, temporal modeling, and fine-resolution blocks. It even pulls in human data, geotagged Wikipedia articles and semantic layers, to add real-world meaning to what it sees. This thing is already deployed. The UN, Brazil's MAP Biomas, and global science teams are using AEF to monitor deforestation, agriculture, urban expansion, even micro changes like shifting sand dunes or wetlands shrinking. And here's the wildest part. You can generate a map for any day. You don't need new satellite passes. You don't need to stitch datasets. AEF builds on-demand, coherent, multimodal, high-res maps, ready to plug into Google Earth Engine. No GPU clusters needed, and no massive teams. Just plug in and get to work. And they're scaling it further. Finer resolutions, local knowledge, and eventually, dynamic Earth twins. Real-time digital replicas of our planet. Updated as we breathe. So here's the takeaway. In 1 week, Google launched a research agent that beats OpenAI, a machine learning engineer that meddles on Kaggle, and a planetary intelligence system that rewrites how we understand Earth. They're not building tools anymore. They're building autonomous agents that reason, adapt, collaborate, and evolve. Now, here are the questions. Which of these do you think poses the biggest power shift? The researcher that outthinks? The coder that outbuilds? Or the satellite that sees all? Drop it in the comments. Smash the like button if this got your gears turning. And if you want more unfiltered breakdowns of what's really going on in AI, hit subscribe. This is AI Ascension.